So we've got an example of a non-regular language that is context-free. So when we say that a language is context-free, we're saying that it equals, that it is the language generated by some context-free grammar. Okay? So the last one is one that I left for you to play with. And what we saw last week is that it's recognizable by a PDA. And in fact, all of the examples that we've seen today are each recognizable by a PDA. So we have this nice theorem that a language is context-free if and only if some PDA recognizes it. So you want to think about this theorem as analogous to the theorem that we had at the end of chapter 1. The chapter 1 theorem said automata, DFA, and NFA are equally expressive to regular expressions. This chapter 2 theorem is saying context-free grammars are equally expressive to push-down automata. Okay, so in both of these worlds, at both of these levels of complexity, we have multiple ways of determining that level of difficulty of problems. Okay? In the simplest world, the regular world, we have DFAs, NFAs, and regular expressions. So we have both that computational left-to-right model that processes a string and says yes or no. And we also have that descriptive model of regular expressions that talks about the patterns that are allowed. In chapter 2, our two models are similar. One is a computational processing model, but now that has this unbounded stack that we allowed to use as memory. And then we also have this more descriptive building up of strings type approach that tells us how we can parse strings as part of this context-free grammar.